Okay, so now we're going to move on to a numerical exercise with heterogeneous firms. And what we're going to do is we're going to consider a monopolistically competitive firm facing demand Q equals S times 1 over N minus B times P minus P bar. And so if you'll notice, this is the exact same demand as we've had before. There's no real change. And so question 1 is going to be to express price as a function of quantity PQ. And so the first two questions and part of the third are fairly familiar. If you'll recall from section 7, I went through the math assuming that firms weren't homogeneous first, and then went back and filled in the math if they were homogeneous. So if you have any questions about the derivations here, you want to see them in a little bit more detail, I cover them in a little bit more detail in section 7, so I'll ask that you go back to section 7 and go through some of that in more detail, because I'm going to go through it just sort of a little bit quicker here. But if you feel like it's too quick, feel free to go through section 7, that video again, and hopefully that will be spelled out in a little bit better detail there. Okay, so first what we're going to do is we're going to express price as a function of quantity. That's question 1. And so starting off with our demand function, we just now want to write price on the left-hand side and quantity on the right-hand side. And so to do that, we're just going to multiply in our initial demand, we're just going to multiply everything through by S, carry that out. In line 3, what we're going to do to get there is we're just going to add BSP on both sides and subtract Q on both sides. And then to get from line 3 to line 4, we just divide by BS. So that gives us that the price that our monopolistic competitor is going to charge is equal to P bar plus 1 over NB minus Q over BS. Question 2 is going to be to find the marginal revenue as a function of quantity. As I said, we've done this before in section 7. Note that if revenue is equal to P of Q times Q, then marginal revenue, you just use the product rule to note that marginal revenue is equal to P of Q plus P prime of Q times Q. And so this first term, I'm just plugging in for what we've solved for P of Q from question 1. And then note that if P of Q is given by this expression, then the derivative of P with respect to Q is just minus 1 over BS. And so we plug that in here, and then we just multiply that by Q. And as it turns out, the result we're going to get is that marginal revenue is equal to P bar plus 1 over NB minus 2 Q over BS. So if that looks familiar, that's just because if you note that here for price, if we put price on the y-axis and quantity on the x-axis, then note that P bar over P bar plus 1 over NB is our y-intercept, and then here negative 1 over BS is our slope. And so here, just note that our slope is just multiplied by 2, so our slope of marginal revenue is twice as steep, but our y-intercept is the same as in price. And this isn't by accident. If you note that, if you just compare the expressions, note that sort of when we're in a setting with linear demand, we're always going to have the case that marginal revenue has twice the slope and the same y-intercept. So let's move on to question 3. And in question 3, we're going to suppose that a firm has a constant marginal cost of C, and we want to express operating profits as a function of C. So if you don't know what operating profits are, you might be stuck here for a little bit, but just to give a hint, operating profits are given by the price minus the marginal cost times Q. And so this is basically going to be profits that are considering all costs except for the fixed cost entry. And so operating profits might be useful insofar as that if I'm a monopolistic competitor and I know that if I enter a market, I'll produce a quantity Q, charge a price P, and have to pay some marginal cost of production, C, to produce each unit, then operating profits can tell me well, given a fixed cost that I would have to pay to enter that market, am I going to make profits such that I cover the fixed cost, or am I not going to be able to make enough profit to cover the fixed cost, and therefore I shouldn't enter the market? So this is how we're going to use operating profits here to analyze whether or not a given monopolistic competitor should enter a market. And so, of course, we're going to want to ask the question of how operating profits are going to depend on marginal cost C. And so, to start off, first we want to figure out what the firm is going to, what quantity the firm is going to produce in optimal. And so I went through the steps to show this in section 7, so I'll refer back there. But the rule that's going to tell us the profit maximizing quantity that the firm is going to produce is the familiar expression of marginal revenue equal to marginal quantity. Marginal cost, excuse me. And so in order to solve for a Q that's going to maximize profits for a monopolistic competitor, we set marginal revenue equal to marginal cost and solve for Q. And so what that gives us is that we just plug in marginal revenue that we solve for on question 3, set that equal to marginal cost. And then it turns out that that's going to give us that at optimum, our monopolistic competitor is going to produce Q equal to BS over 2 times P bar plus 1 over NB minus C. Okay, and so now, given that we've produced that Q, we're just going to plug Q into our expression of price as a function of quantity. And so what that will ultimately give us is half times P bar plus 1 over MB plus C. So you know, there's a little bit of basically algebra to do here, but again, once you have Q from the marginal revenue equals marginal cost rule, you're just plugging it into price as a function of quantity to get the optimal price that a heterogeneous monopolistic competitor is going to charge. Okay, and so now we have all of the ingredients to solve for what my operating profits are going to be. Okay, and so to help show what operating profits are going to be, I've just rewritten the optimal quantity that a firm produces and the optimal price that it charges out on the board. And then I've just rewritten the expression for optimal profits, where this is pi OP to represent profits that are operating profits. Okay, so what I'm going to do is I'm just going to start off by plugging in for P. And so at first, what's going to help us is I just want to write out, I'm just going to multiply out each term by half. So what this is going to give me P bar over 2 plus 1 over NB times 2 plus C over 2. Okay, so I'm just going to plug this in. So P bar over 2 plus B plus C over 2 minus C times Q. Okay, so you can know that these C's are going to combine, and what we'll get is we'll get P bar over 2 plus NB times 2 minus C over 2, still times Q. And now I'm just going to plug in for Q. And so what I'm going to get is I'm going to get that this is BS over 2 times P bar plus 1 over NB minus C. Okay. And so now what I'm going to do is for this first term, I'm just going to pull out each of these terms is multiplied by just by 1/2. So I'm just going to pull out 1/2. What that will leave me with is half times P bar plus 1 over NB minus C times BS over 2, again, times P bar plus 1 over NB minus C. Okay, and note that these terms are identical. So what we'll be left with is we'll just have to multiply 1/2 and BS over 2 together. So what we'll get is BS over 4. And then these terms are basically just, can be combined into saying that it's just this term squared. And so our operating profits are going to be given by BS over 4 times P bar plus 1 over MB minus C squared. And so this slide is saying what I did on the board. Again, it's just saying that if operating profits are going to be given by P minus marginal cost times Q, then we've just plugged in for P, MC, and then the quantity, and it turns out that will give us our result. Okay, and so notice that operating profits are going to be negatively related to C. So less efficient firms are going to produce less, and you can see that they're going to produce less because going back to going back to the quantity produced, sorry, that took a while to get to. Going back to the optimal quantity produced, note that this is decreasing as C gets higher. So if I'm a less efficient firm, I'm going to produce less output. If I'm a more efficient firm, that is, if my C is lower, then I'm going to produce more. So I'm going to sell more. And so it would make sense that the same relationship is going to hold between marginal costs and operating profits. If I have a lower marginal cost C, then I'm more efficient, and so you would think that I'd have higher operating profits. Okay, so now question 4 is going to say, given that we've solved for what operating profits are going to look like as an expression, now we're going to give some values for S, N, B, F, and P bar, and then we're going to take into consideration the perspective of a potential new entrant. And what we want to ask is, we want to calculate their operating profits, and we want to ask whether or not they'll be willing to enter this market, given that they have to cover the fixed costs. And so what we have is that at the optimum, we can figure out what quantity the firm is going to produce. So the first line is just restating the general expression for how much a monopolistic competitor is going to produce. And then all we're going to do is we're going to plug in for the values given to us above. And so we can just plug those in and do some computation. And so it turns out that will give us 7.045. And so notice that that's greater than 0. And so if the monopolistic competitor here is going to enter the market, then they would like to produce some positive quantity. So now what we need to figure out is whether or not the firm, taking into account its operating profits, is going to recover its fixed cost. And so again, we take the expression for operating profits that we derived earlier, and we just plug in for all of those new values. And so it turns out that if we plug in those new values and just go through the computation, it turns out that our operating profits are going to be 4.96. However, operating profits are going to be less than the fixed cost of entry, which is 10. And so we're going to think that this potential entrant has too high of a marginal cost to be able to enter. It's going to be too inefficient, because if it does enter, then it has to pay $10 just to enter the market, and then it'll only make from there operating profits which don't consider the fixed cost of 4.96. So essentially, if it enters the market, it will lose roughly $5 in. It will lose roughly $5, and so thinking prospectively, this monopolistic competitor would not choose to enter this market. So, so just to recap, in question 4, we take the general result of operating profits that we calculated in question 3, and just plug in for all the values, and then compare it to the fixed cost and say, well, looking forward, would a firm want to enter? And in this case, it's no.